Before solving an example problem, recall the steps to performing any significance tests. The first step is to write the null and alternative hypotheses. The second step is to determine the level of significance. The third is to choose and perform a test. The fourth is to find the p-value. The fifth step is to interpret the results, and the last step is to draw conclusions. A coffee shop claims that the mean amount of coffee in their 16-ounce cup is 16 ounces. To test this claim, a random sample of 36 customers is selected, and the amount of coffee in each customer's cup is measured. The sample mean is found to be 15.8 ounces, with a standard deviation of 0.4 of an ounce. Using a significance level of 1/100th or 1%, can we reject the null hypothesis and conclude that the mean amount of coffee in a 16-ounce cup is different from 16 ounces? Let's get started. The first step is to determine our null and alternative hypotheses. Well, our null hypothesis is provided in the problem. It matches the claim that the mean amount of coffee in their 16-ounce cup is 16 ounces. In other words, mu is equal to 16. And then the alternative hypothesis will be the opposite of this, that mu is not equal to 16, or that mean amount is not equal to 16. And again, this is referencing where mu is the actual mean amount of coffee in a 16-ounce cup. Notice that this is a two-sided test because of the sample standard deviation of 0.4 of an ounce. Next, let's check the conditions for performing the test. To test the claim, a random sample of 36 customers is selected. So this is our random sample, or the first condition that needs to be met. And because they did a random sample, that appears to be enough to proceed or to look at our second condition, which is the 10% part. They surveyed or conducted the random sample on 36 customers, and it makes complete sense for the customer total to be more than 360, which would then make the 36 be 10% or less. And then the third condition is about the normal to large sample. Well, because it was 36 customers selected, that is greater than 30, so the last condition is satisfied also. So all three conditions are met. Since all of our conditions have been met, we can perform a one-sample t-test for a mean. The first key piece of information that we need to find is the sample mean, and that value is 15.8 ounces. We also know that the standard deviation is 4 ounces. Also, since we know that the random sample of 36 customers is selected, that's our n value. And then the degrees of freedom is one less than that, which is 35. The final piece that we need is the mean from our null hypothesis. And the mean in our null hypothesis is 16 ounces, or 16. And then we can plug these values into the formula, that t is equal to our sample mean minus our mean from the null hypothesis, all divided by the standard deviation divided by the square root of n. If we substitute these values into the formula, we end up getting 15.8 minus 16 divided by 4/10 over the square root of 36. And if we actually simplify this, we'll end up getting negative 2/10 in the numerator, and in the denominator, we'll get 4/10 divided by 6. And then because we have a fraction in the denominator, we can multiply both the numerator and denominator of our bigger fraction by the reciprocal. So that's 6 over 4/10, 6 over 4/10. And when we multiply that, we will get negative 1 2/10 over 4/10. And then if we multiply both the numerator and denominator by 10, it'll become 12 over 4, negative 12 over 4, which equals negative 3, with the degrees of freedom of 35. We just calculated our t-value to be negative 3. And using a two-tailed t-distribution table or calculator at significance level of 1/100th, we can find the p-value for this test. So if we put in the t-score of negative 3 with the degrees of freedom of 35 and the significance level of 1% or 1/100th, and we want two-tailed, and after pressing the calculate button, the p-value is 0.004949. This p-value is much less than the significance level of 1/100th, so we can therefore reject the null hypothesis. And the reason we use two-tailed in this problem is because our alternative hypothesis is two-sided. If we needed a one-sided alternative hypothesis, then we would respectively use a one-tailed t-table. And we can draw a conclusion based on our results. We do have enough evidence to conclude that the true mean amount of coffee in a 16-ounce cup is different from 16 ounces. Therefore, the shop's claim is contradicted by the data at a 1/100th or 1% level of significance. As you would expect, the link between a two-sided significance test and a confidence interval is even stronger for population means than it is with population proportions. A two-sided test, where at the null hypothesis, stating that the mean is equal to the mean in the null hypothesis at a significance level of alpha, provides the same conclusions as 100 times 1 minus alpha made into a percent confidence interval for our mean.